Hello, today we're going to look at the connection between binomials and normal distributions. Now, a sample of 2,500 adults were asked if they agree or disagree with the statement. I like buying new clothes, but shopping is often frustrating and time consuming. Suppose that 60% of all adults actually agree with this. What would be the probability that 1,520 or more of the sample would agree? Now, we're going to solve this in two ways. The first way we're going to solve this is using our calculators and using a CDF. So we want to find out the probability that 1,520 or more, so more than 1,520 agree with this. So if you were going to do a cumulative distribution function, you know cumulative distribution function, this is going to look pretty tall shape. 1520 is going to be here, and the CDF would be everything below, but we want everything above. So the quick way on our calculator is to do Binomial Cdf, which goes for, there's 2,500 people. The probability of success is 0.6. And let's see, now this is greater than, or actually 1,520 or more. So we should put an equals in there. So our x value is 1519. And then that is the percent that's on the left. So if I want to find what's on the right, I just take 1 minus that value, and that would be 0.213. Now, that's a great answer. And the only downside about that problem is AP will not give you credit for this because you didn't show any work. Even if you did one minus the other one, it's still not good enough. So we want to look at a normal approximation. Now, before you do a normal approximation, binomials, in this particular problem, you can see the binomials in blue, that is really close to a normal distribution. You can use a normal approximation whenever n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Now, these two things you'll have to remember for the next 6 chapters. You'll be doing them for the rest of the year. So you should get used to it now. We'll have to prove that it's a normal distribution before we can use our normal approximation. So our n is 2,500. Probability of success is 0.6. We just have to multiply those to see that they're more than 10. And they're way more than 10. And if we multiply by 0.4, so 2,500 times 0.6, that's 1,500. That's way more than a 10. And then times 0.4, these two numbers have to add up to 2,500, so I know that that's 1,000. We could plug it in our calculator, but these two will always add up to that number. So both those are greater than 10, so we can say we can use normal approximation. My screen's not writing. All right, so we want to find 1,520 or more. So we want to find the probability x is greater than or equal to 1,520. Now, we want to convert that to a z-score. 1,520 minus the mean. We don't have a mean in the problem, but we did find out in our last video that we could find the equation for a mean by taking our number, 2,500, and multiplying it by our success, which we've already got to be 1,500. Our standard deviation we'll get by taking the square root of 2500 times 0.6 times 0.4. Just plug that into our calculator. And take the square root of 600 to get 24.494. So now we just plug in those values in here. So I have 1500, 24.494. And now we're going to get a z-score. Pause the video. I got a z-score of 0.8165. So now that we're using this normal approximation, I'm going to do a normal CDF from 0.18165 to an upper number because it's greater than, and then paste that, and we got 0.207. Now this one and this one aren't exactly the same, 0.213 and 0.207, but it's close enough where this gives us a good amount. It's close enough. Now remember, we can only use our normal distribution when we have these values, and we have to check them. We can't just say, yes, it works. We have to actually plug in the numbers for n and p and see that, that this is true. Because the binomial only looks like a normal when the n gets very, very large, the number of trials. Now, if a football kicker makes 30-yard field goals 80% of the time, could we use a normal approximation to see if the probability of kicking 18 out of 20 field goals? And the answer should be no, because 20 times 0.8 will be 16, but 20 times 0.2 is only 4. And so 4 is below 10, so this would not be a good use of normal distribution. The probabilities would be off. So if you want to find out how many you would have to kick, well, with 0.8 as the number, n times 0.2 has to be greater than 10. You divide both of these by your value, and you see which of them is the highest number. So you can take 10 divided by 0.8, and you get 12.5. And you get 10 divided by 0.2, and that would be 50. So n would have to be greater than or equal to 50 in order to use a normal approximation. All right, hopefully you can do your on your own.